During this video, you will learn the basics of preference modeling. Preference elicitation is yet another format of expert elicitation. Typically, discrete choice or preference of experts over alternatives is elicited. We can ask expert to compare alternatives A over B, B over C, and A over C, and from their answers infer positions of atoms A, B, C on some relevant scale, usually utility scale. This type of elicitation is often used amongst the others in econometrics and marketing. Let's consider a simple problem. Of what product should the vending machine at our university offer? This problem has been studied by Laura Middeldorp as a bachelor project. You can see her photo on the slide. The idea of Laura's bachelor project was to investigate preference of students and the scientific staff at the university over snacks. Few healthy options, as an apple, a rice cookie, and a muesli bar were provided. Moreover, one savory alternative of a bag of crisps was given. The rest were high-calorie sweet treats, a Snickers, an almond paste cookie, and a sponge cake. The goal of the study was to discover market shares of these products, thus the expected percentages of sales of these products when introduced as choices in the vending machine. An internet-based questionnaire was developed and sent to the participants. Experts compared products pairwise and gave their answer to questions. Do you prefer an apple or a Snickers? Do you prefer a bag of crisps or a Snickers, etc. Let's look at the results of comparisons provided by expert 1. We can see in the second row of this table that he chooses an almond paste cookie over a bag of crisps. Similarly, a rice cookie is preferred by an expert over crisps. However, when he has to choose between a bag of crisps or a Snickers, a sponge cake or a muesli bar, then expert 1 picks crisps. In the last row of this table, we can observe that expert 1 chooses always an apple over all other alternatives. In general, this expert prefers snacks which are quite healthy and not too calorie dense. Expert 2 has different preferences as compared to expert 1. This expert prefers a bag of crisps over all alternatives except the sponge cake. In row 6, you can see that sponge cake is the favorite snack of expert 2. He prefers it over all other alternatives. 79 people participated in the elicitation study and each provided 21 pairwise comparisons of 7 snacks. The number of experts that preferred I to snack J is presented in the data matrix N, shown in this slide. We see that an apple is the most preferred snack by this group of experts. Consistently, more than a half of them prefer an apple to other alternatives. A bag of crisps is chosen by more than a half of experts, except in the case when it is compared with an apple. The preference of other snacks are not as clear as in the case of an apple and a bag of crisps. In order to find the market share of each snack, we propose a simple model named after 2 scientists, Bradley and Terry, who presented it in 1952. In this model, to each product, a non-negative preference potential, denoted as pi I, is assigned. These preference potentials are assumed to be constant. They do not depend on when and which products are compared. The probability that product I is preferred to product J is equal to the ratio of preference potential of product I to the sum of potentials of product I and J. It is easy to see that Pij's would not change if pi i's were multiplied by a non-negative constant. Thus, to be able to recover a unique set of preference potentials, an assumption that they add up to 1 is included. The preference potentials, which are parameters of Bradley-Terry model, can be estimated from the matrix N, but by maximizing the likelihood. The likelihood function is simply the product over all pairs of alternatives of the probability that the alternative I is preferred to the alternative J to the power of the number of experts who preferred I to J, hence to the power of Nij. The estimates of preference potential are found by solving numerically equations or by using a recursive MM algorithm. The estimated potentials of the 7 snacks using data elicited from 79 experts are shown in the table. As we expected, the largest preference potential of 0.3 is estimated for an apple, followed by the preference of potential of a bag of crisps equal to 0.2. The preference potentials of other snacks are quite similar. These results allow us to draw a few conclusions. Namely, we can expect about 30% sales of apples and 20% sales of crisps when they are introduced as a choice in a vending machine. Moreover, according to our 79 experts, the preference ranking of 7 snacks is as follows. First, an apple, then a bag of crisps, followed by a sponge cake, a Snickers, a muesli bar, a rice cookie, and finally an almond paste cookie. Using estimates of preference potentials, we can compute the probability that an apple is preferred to a bag of crisps, which is equal to 0.6. The probability that an apple is chosen when compared with an almond paste cookie is much higher, is equal to 0.81. However, the choice between a rice cookie and an almond paste cookie is pretty much 50-50 chance. Finally, we point out one problem that can occur during the preference elicitation. It can happen that an expert, when asked to choose an apple or a Snickers, picks a Snickers. Then he prefers crisps over Snickers, and finally an apple over crisps. This is an example of an intransitive or inconsistent choice called circular triads. The number of circular triads in an expert's paired comparisons data can be an indication of consistency or quality of this expert. We can decide to remove from the data assessments of experts containing too many circular triads. Circular triads can appear in expert assessment due to too large number of comparisons that he is forced to provide. To tackle this problem, paired comparisons design required not all, but only necessary pairs of alternatives to be assessed are available. Existence of circular triads in pairwise comparison data could be also caused by the lack of strong preference between the certain alternatives. To remedy this problem, in an extension of Bradley-Terry model is allowed data where experts state no preference over some alternatives. You can read about these topics in extra material available at the end of the module. Thank you for your attention.